Hi, a very good afternoon, everyone. Thank you. I've given many speeches in the university, in networking events, but this is really the first time where a lot of my friends are here, my own friends, lawyers, judges, medical doctors, all professionals. I think it's very rare to see so many professionals in a networking event. So today, I am very honored to be able to share with you some of the insights behind this very, I would say, fantastic product. But before I talk about the product, I think you need to understand the story behind this product. How is this product going to be formed, and also the scientific principles behind this product. This is not just a product. There's technology. There is also tremendous effort in product development. There's also a lot of tests being conducted, especially with A-STAR, our Singapore leading scientific institution. So maybe let me just share with you today, all right? Imagine something, all right? Imagine now in this room, just imagine now in this room, there is no electricity. No electricity. That means today, now, at this moment, there won't be any lights. There won't be any screening. There will not be also any sound. Today I speak, the mic will not work. Now, why am I trying to let you have this kind of imagination? Because our nerves, right? You understand what is nerves, right? A lot of times, we underestimate the importance of our nerves. We always take for granted. But the nerves that we have actually help to serve as electricity. So just imagine today, without electricity, all right, can our body ever function? You understand what I'm trying to say? It's like no electricity. It's like no impulses. So, therefore, if you understand the importance of electricity, then I think all the more you should listen further, all right? Because today, the electricity or the electrical impulses that's happening in our body needs to be maintained, all right? It needs to be maintained because nerve cells, once it is destroyed or once it's damaged, it is very difficult, very difficult to repair, to recover. And most importantly, you cannot even make new nerve cells. So a lot of times, we are born with only a certain number of cells, of nerve cells. All right, now, you can understand from the screen, when we are born with almost 100 billion of nerve cells, and about there, right? Every one of us is about there. So 100 billion of nerve cells. People who know me for many years, they understand that I'm actually a stem cell researcher. Stem cell, it's very different from nerve cell, right? Stem cell, we all know that, different parts of our body have stem cell, and stem cell can regenerate. That means can reproduce. So I'm quite famous also in terms of stem cell production, but this is the very first time that we make some very fantastic breakthrough in nerve cell. Because nerve cell, the stem cell of nerve cell is very different from the stem cell of other parts of the body. Very different. And today, all right, I've given so much speeches on stem cell, but today is the very first time I'm talking about nerve cell in front of so many of my close friends here. So 100 billion of cells we have. But can I just let you know that as we age, okay, from 10 years old, 20 years old, 30 years old, and some of you here maybe even 60 years old, 70 years old here, the number of nerve cells that we have in our body diminishes. diminishes as time goes by. Even now, at this second, at this very minute, as you are listening to me, nerve cells is dying. Nerve cells are dying. Okay? So the question is, how much or how many of these nerve cells can we afford to lose? How many of these nerve cells can we afford to lose? We say, oh, okay, we have 100 billions of cells. Never mind, so many cells, billion, you know. So how many of us think that, well, if this becomes the money in our bank, that'd be fantastic, right? 100 billion. But this is 100 billion of cells. But I can tell you, because of, in this modern world, we are living in a world where it's full of pollution, okay, also with the food that we eat, also the water that we drink, damages our nerve cell. And every second, including smoking, all right, including smoking, every second, you know, it could be thousands of nerve cells dying. Just imagine, 1 day or 1 second, 100 cells dying. In 1 year, how many of cells can die? And these cells cannot be replaced. Understand? Cannot be replaced. So if you're born with that cells, you live with that. And so by the time we reach 60 years old, just imagine, by the time we reach it until 60, 70, 80 years old, how many of the nerve cells are left? It's not many. So there is a very serious consequence. Later on we'll see, if we lose those cells, what will happen to us? But before that, let me just give you some very academic kind of classification, at least let you know what is the nervous system. Okay, because a lot of times we know that we have nerves, but we don't understand our nervous system. Very few of us know that. So the nervous system, actually we have the central nervous system, which is comprised of the brain and the spinal cord. And then, of course, the brain and the spinal cord are very important, we know that, right? Because the brain controls everything, every activity of our body. The spinal cord, it is also very important because it is also part of the central nervous system. Now, just imagine if any injury that goes with your spinal cord, that can be, you can get paralysis. We all know that, and it can be permanent most of the time. Now, after the central nervous system, we have also what we call the peripheral nervous system. All right, and under the peripheral nervous system, you have the somatic nervous system, which controls all your muscular activity, all your physical activity. All right, so today, as I lift my hand, it's all voluntary because I control it. But there's a lot of things inside your body. There's a lot of things inside your body, a lot of activity inside your body that is not muscular, that is not skeletal. Skeletal-based means, what do I mean by that? So that is actually what I meant by involuntary control. Involuntary control. Now imagine today your pupil. Now there's full light here, and our pupil are maybe small in size. And when you go into a very dark room, the pupil suddenly open in size, and that is involuntary control. And even your heartbeat, you know, it's all involuntary. And even today you pass motion. That is involuntary control. A lot of activities inside is involuntary. And this is controlled by two sets of nerves. One is the sympathetic nerves. The other one is the parasympathetic nerves. Later I explain to you what does these two sets of nerves do. And if I'm you, I will really pay attention, because this affect all of us here. What do these two sets of nerves do? Basically, it provides involuntary control over the smooth muscle, right, including your intestines, peristalsis, because today after a meal, for example, you have digestion, right? And then digestion and even your colon movement and all these things, these are all smooth muscle. Smooth muscle. So smooth muscle is not under the control of the brain. It's not under the control of the brain. Now, of course, that's why it's called involuntary. Cardiac muscle that helps the heart to contract. And of course, glandular activity, glands that secrete hormones. Now, how many of you know what is hormones? I believe some of you know what is hormones. Hormones are very important because without hormones, all right, in our body cannot coordinate. Like, for example, one very good example I can give you is that women undergo menstrual cycle, right? Menstrual cycle. Now, every day, every month, the period comes, right? And it's quite regular. What is it regulated by? It's regulated by hormones. You understand what I'm trying to say? Pregnancy, regulated by hormones. Now, just imagine if everything goes haywire, and pregnancy becomes non-pregnancy. That kind of thing can be quite drastic. So hormonal control is very important, and that is controlled by the involuntary muscles called the autonomic nervous system. So just understand what is autonomic nervous system. And this autonomic nervous system is so important that it even helps you to maintain and control the brain, your brain, and the spinal cord. Now, the brain is a very important organ, but even the brain needs something to tell it to do something, because the brain cannot control itself. The brain cannot control itself. So the only thing that can control the brain is this autonomic nervous system. You understand what I'm trying to say? Because even the brain itself needs to have activity. The activity itself within it is managed by the autonomic nervous system. So this autonomic system, two sets of nerves. One, increases your heart rate. Sympathetic nerves increases your heart rate, constrict your blood vessels, raise blood pressure, fight or flight response. That means if you are going for war or you're going to fight something, the sympathetic nerves will be activated, stimulated, or even if you are running for life, let's say a mad dog or a mad man is chasing you with a knife, you're trying to run, that sympathetic nerves are going to be activated, stimulated. Now, on the other hand, you have what we call the parasympathetic nerves. The parasympathetic nerves slow down the heart rate. It's actually opposite in action, almost opposite in action. Increases peristalsis of intestines. Increases granular secretion. Relaxes the sphincter. The sphincter is actually the muscles that control the opening of your anus and all other openings. Very important. Now just imagine any of these things went wrong, you can have blood pressure, high blood pressure, you can have diabetes, you can have all kinds of diseases coming to you if all these things are, become dysregulated. So here is just to give you an overview, why is the autonomic nervous system so important for us? It's just like electricity. It supplies impulses to all these organs from the pupils, the eyes, to the lungs, to the heart, the liver, all our vital organs, including the kidney, the stomach, and including your bladder. How many of us, have seen patients, at night, you cannot control your urine. You cannot control your urine. No, I believe all of us can control our urine, but some people among us, or some friends among us, at night, you just wet the bed. Adults, we're talking about adults. So these are what we call something went wrong. Obviously, something went wrong, and, the bladder can be affected. Even sexual activity, all right? You don't need a Viagra to stimulate the penis, all right? In fact, all right, the sympathetic nerves, the parasympathetic nerves can actually help, the penis to be aroused. You understand what I'm trying to say? So what I'm trying to say is that the blue ones represent the parasympathetic nerves. The red one represent the sympathetic nerves. So the autonomic nervous system is not to stimulate activity. It's not. It is about stimulating and relaxing. You need a combination. You need to relax sometimes. You need to stimulate sometimes. You understand what I'm trying? Not every time you need to be at the stimulated state. So you need to control. So in other words here, what I'm trying to tell you is that there must always be a balance. There must always be a control in a sense that, when things got too excessive, you have to bring it down. When things got too low, you have to bring it up. And how to do that? Because the body has to have something to do it. So that actually involves what we call a system, and that system is called autonomic nervous system. So that is important. So I've established the importance of the autonomic nervous system. Now, what can actually destroy? Because the autonomic nervous system is served by a huge diversity of nerves and nerve-related cells. You understand what I'm trying to say? So as a system, autonomic nervous system is not just one cell, or not just one type of cell. It is a group, a combination, or a huge diversity of many, many different types of nerve cells. There are many different types of nerve cells. So any one of these nerve cells, if they got damaged or they die, it could therefore affect the autonomic nervous system. It could therefore affect the autonomic nervous system. So let's see now what can actually make nerve cells to die. Accidents, drugs, alcohol abuse, not alcohol, but alcohol abuse, okay? And then, of course, disease, including autoimmune disease, diabetes, all this can help to destroy the nerves. Of course, aging. Aging can help to destroy the nerves. Now, how does the drug and alcohol, abuse destroy the nerves inside our body? Now, imagine this is a nerve cell. Imagine this is a nerve cell. This is the connecting nerve cell, because the nerve cell need to communicate. So this is connecting nerve cell. So there must be neural activity. So what happens is that when you drink too much, or when you even take a drug, and that's why sometimes drugs can give you side effects. If you take a chemical drug like ecstasy, for example, ecstasy, we all know what is ecstasy. So ecstasy actually binds to the receptor of the receiving cell, such that it will not fall off again. That means to say that that receptor becomes useless. And if, let's say, that this nerve cell was to want to receive nutrients or growth factors from the food or from whatever, from the external stuff around it, it is no longer able to do so, because the drug binds irreversibly on the receptor. And when all these receptors are being occupied or being what we call irreversibly bound, what happens is that this nerve cell shrink and die, all right? And die because it just does not receive the nutrients anymore. So what happens is that, if you take too much drugs, therefore, you can see, all right, whether it's opiates or whatever, these drugs will actually bind onto the brain cells, and therefore making these brain cells less accessible to other more important nutrients. And in the long run, the brain cells there, all those that are bound by receptors, will die. And when they die, as I was telling you, it is not reversible, that you cannot make new nerve cells, and therefore the onset of diseases will come. The onset of disease will therefore come. All right, so just to let you know, all right, a normal person under normal scan, all right, is this color, but a drug abuser, okay, you can have a different kind of color under the brain scan. Okay, and you can see that a drug abuser from a normal person, the brain is still normal, but the drug abuser, the brain is very, very damaged. It's very damaged. Now, different parts of the brain give rise to different types of outcome. And all of these outcomes are very, very important, because some of the outcome could be movement, sensations, even vision. Vision can be controlled by the brain. And of course, judgment and memories and coordination. So if the neurons die at that area of the brain, that means movement and sensation will be impaired. Will be impaired. And if it happens there, then you have no judgment. That means to say that you don't know what is right or wrong. And then sometimes you cannot even recognize your loved ones. And then of course memory. All right, a lot of times we just forget things. Why? Why is it so that we forget things? All right, it's because some of your nerve cells die at that region. And of course, reward as well. You don't know what is reward, you don't know what is punishment anymore. So a bit of dementia there. And coordination. This part, the back end of the brain, is more for vision. right? If this portion of the nerves are dull, then you start to see